Thanks for coming. My talk will be about the future of JavaScript, and we'll talk about what is still missing. So, what can you expect? In recent years, JavaScript has grown considerably, and then the question remains, is there still stuff missing? And that's what I'd like to talk about. I'll only be talking about the features that I personally consider most important. So the list is subjective. And I'm not saying that there are not other features that are useful too. On the other hand, there's always a risk you may add too much, and there's a risk of bloating the language. And I think at the moment, we have reached a nice closure, like a nice intermediate state within the language, especially with with async functions and async iteration. You have it's quite well rounded now, and we'll talk like a few things I think are still missing, and we'll get to these. And all the features, or most of the features that we look at, are actually officially proposed features. So there's a website, the TC39 website, where you can get a list of everything that's in the pipeline for JavaScript. So you can take a look at that as well. And at the very end, I will give you a link to more reading material where you can look up more details, and it will have all the necessary links. So you can take like screenshots in between or take notes, but you don't have to. Before we dig into the features, I'd like to give you a little bit of background knowledge, and that is, I'd like you to know how JavaScript is being evolved and designed. So, there's a difference between JavaScript and ECMAScript. So this word, ECMAScript, is always floating around, and you read it a lot. But the question is, what is it really? I mean, it's always used more or less synonymously with the word JavaScript, with the term JavaScript. But there's a subtle difference when it comes to how it is used colloquially. And that is, whenever you hear the word ECMAScript, it relates to the standard of the language. Thus, when you read something like ECMAScript 5, it means edition 5 or version 5 of the language standard. And otherwise you read JavaScript, and then it's just basically the language. And the reason for this distinction that I'm not aware of any other programming language that makes this distinction is that there is a trademark for JavaScript. Oracle has that trademark, and that's why you can't use it for anything open unless you have a license from Oracle. TC39. Who has heard the word TC39 before? Raise your hand if you have. All right, okay, that's plenty of people. I'm guessing 80-90%. So TC39 is the so-called Technical Committee 39, and these are the people that evolve and design JavaScript. And what's nice about it is that it's actually a very diverse group of people, whereas in many other languages, it's a closed group and not a lot of parties have input. For example, Java, I think, is mainly controlled by Oracle. I think they now have some kind of a more open process, but still the general direction is dictated by Oracle. And with JavaScript, really multiple or many companies are involved in deciding where JavaScript is heading. So that's really nice. And so strictly speaking, the members of TC39 are companies, and these companies send delegates to meetings that happen every 2 months. And these meetings are also occasionally attended by invited experts. So it's a mixed group of people. The TC39 process, who of you has heard of the TC39 process with the stages? Raise your hand. Right. I'm guessing 80%. The trigger for this kind of process was that ECMAScript 6 was a huge release and arguably too big. And if you have these large releases and the time between the releases is long, then you have a problem, because sometimes you have smaller features and you could already standardize the smaller features because they're ready, but you have to wait until the next version is being released of the language standard. On the other hand, you may have big features that are not quite ready yet. And that feature is then under a lot of pressure to get finished in order to make it until the deadline. And arguably, ECMAScript modules is one of those cases where it was added to the language standard before it was like really implemented everywhere. And in response to that, they created this new process, and the idea is now, instead of focusing on these releases, so the releases become less important, you now focus on features. And with the features is, for each feature you have a so-called proposal. That proposal goes through stages from 0 to 4. And every year you have a new release. So the deadline is more or less, it's the same each year, but it doesn't really matter when it is, because it's the whole thing is agile now, and whenever the deadline is, every feature that is ready by that time becomes part of the standard. So the general tip now is, whereas beforehand this whole thing about ES5 versus ES6 and so on, now you can think less in ECMAScript versions, because there's now so many. Is ECMAScript 2016 or ECMAScript, or for example, async functions are the part of ECMAScript 2016 or 2017 and so on. You can't be quite sure. So now we're thinking actually in features. And that is nice because everything is very agile. And very often, once a feature reaches ECMAScript, reaches stage 4, it's done. And basically you can start using it. You still have to check what browsers implemented, but once it is at stage 4, usually the features are already relatively widely supported. So this is a quick diagram of the TC39 process. You can see the different stages. What is kind of interesting are the requirements in between. So the requirement to reach stage 0, and at stage 0 it's still a basic sketch, so not a lot of it is worked out. It's just basically you say, I have this idea, is it worth developing? And even for stage 0, you have to present in front of TC39, and they have to give thumbs up or thumbs down. And then the thing evolves. More and more of the spec text is added. And what I find interesting is that before you can get to stage 2, there have to be 2 implementations. So that is awesome, because you can be sure that a feature, once it reaches stage 4, has been tried in the wild. So it's not something, traditionally standards were like thought out by a room of experts in isolation and then added onto platforms. And with the TC39 process, it's different. Features are actually tried out in the wild before they become a standard. So that's nice. And then additionally, you have acceptance tests. So there's a whole suite of tests for language features that is called Test 262 from the number of the ECMAScript language standard. That's ECMA 262 is the whole ID. And with these acceptance tests, you ensure that the different engines that exist are compatible, and it's amazing how compatible they are. And well, with the recent move by Microsoft, it's V8 is, yeah.
the two implementations, does Babel count as an implementation?
It does. Very good question. And so transpilers count as implementations.
So if TypeScript and Babel implemented, it's...
I'm not sure they would go along with that, but yeah. But given how widespread TypeScript and Babel are, it's a good way of letting a lot of people try out the feature and figure out the quirks. All right, so as a next step, we're now getting to features I'd like to see in the future and kind of features that are on the roadmap for JavaScript. So let's start with a little bit of background. We already talked about this in a small group here yesterday. Occasionally you hear the sentence, everything in JavaScript is an object. And that's not true because there are two kinds of values, and thankfully the distinction between the two kinds of values isn't too important. So very often you're fine if you ignore the distinction. And the distinction is you have primitive values and you have objects. And primitive values, so string is a primitive value, and all primitive values, so other examples are booleans and numbers and symbols, and this is strings. And if you compare these, they're compared by value. So you look at their contents. You look what's inside the value, and if the content is the same, then the value is considered the same. On the other hand, if you have objects and you compare them, you compare by identity. So the only object that is equal to an object is the object itself. And you can see here that intuitively, you probably want something different. Because intuitively, these two objects, they are the same, but we're not comparing by value, we're comparing by identity. So one feature that would be nice to have is objects that are compared by value. And there are two ways this could be added, and those are complementary. So they could add just one of them or both of them. And this is one example of you could introduce a new kind of object literal and a new kind of array literal. And these would generate or produce a new kind of object. And then if you compare those, this new kind of object, it will be true if the content is the same. And the other option would be to annotate a class. And objects produced by that class will be compared by value. So you could implement your own class for points. So that's the canonical example, easy to understand example. Another important issue is that if you work with data structures at the moment, for example, if you use the new map, you have now the advantage that you can put objects, you can use objects as keys, but that isn't really useful, as we see in this example here, because I'm trying to use the same key twice, but I'm actually adding two entries because, again, keys are compared by identity and not by value. And that, apart from weak maps, I can't really think of many use cases for using objects as keys as there are right now. But in theory, it'd be nice if you could actually use objects as keys and have more powerful keys. For example, just an array of strings as a key, something like that. That would be really useful. So solutions include, you could either, once you have value types, the problem goes away. The alternative would be just customize key management via callbacks, and then it depends. At the moment, I guess that the implementation is a hash map, so a hash table. So you need two operations, one for equality and one for a hash code. But you could also have a map that is based on a sorted tree, and then you just need an operation that compares two keys. Next feature that is already firmly on the roadmap and that will become a part of the standard very soon is large integers. So there are quite a few examples of, for example, Twitter. For a while, they stored the IDs of a tweet in JavaScript as a number. And then the tweet IDs became higher, and they went beyond the 53 bits you have for integers in JavaScript, and they had all kinds of bugs. So they have 64-bit keys, the tweets, and they exceeded the 53 bits because the date is in there in some way, in the ID. And what they had to do for the JSON format was they had to switch to strings. But with big integers that are now, or let's quickly look at what this 53-bit limitation, what it means in practice, is this is already this is the highest useful or safe integer plus 1. So here you have already the 992 at the end. There are actually two real integers that map to the same internal representation. So if you add 1 to this number, you end up with the same number. And then the higher you get, the further there's spaced apart. And with a proposal that is currently at stage 3, you would get so-called big ints, and these grow as necessary. So you can get arbitrarily big and can get arbitrarily many bits of precision. And if we try the same here, we use, again, 53 to the power of, 2 to the power of 53. Then we have the 992. If we add 1, we get to 993. And if you look closely at the number of literals, you can see the postfix n here. And that means that the number is a big integer. And the first time I saw it, I thought it was like multiplying with n. So if you, but it's this is a comment. So they looked at what suffix is used in other languages, and n was a reasonably good suffix. And if you want to work with 64 bits, you have the option of casting. For example, here we are creating a 64-bit number. So we're using a big integer, but we cast it to 64 bits. And after you multiply, you cast again. And this is what you do. And you could probably have two functions for that as well. This is how you stay within 64 bits for the rare cases where you need to do so. Another feature that is important, so at one time I tried to do my taxes in JavaScript because it's just convenient. If you have some kind of calculator app and then typing using anything like that, it's just not very convenient. And if you have, I used the Node.js command line, I added up my taxes, and then I started to get the first rounding errors, and I was like, no. And then because you can get real problems, and so for anything that involves decimal fractions, you can't really solidly rely on JavaScript numbers. And the issue is, and this is a classic that's occasionally used to make fun of JavaScript, but actually if you try the same example in, for example, Python, you have the same issue. Because it's JavaScript numbers or doubles, and they're based on an IEEE standard. So it's nothing that's particularly JavaScript-y. So that's not a. There are other ways of making fun of JavaScript, but this is not really one. And here you can see that 0.1 and 0.2 is not something that can be represented well with base 2. And you have a similar example if you have 1/3, for example, that is base 3, and that can be represented as a decimal fraction. It's 0.3 to infinity.
Quick question.
Yeah.
Obviously, that's the literal first type, but what happens if you want to put an input field? Do you have to string it, or like how does that number get represented?
Oh yeah. I would guess that there's some kind of, you would have decimal.parse or something like that, and you would probably be able to cast from a number. That would be another way. Good question. And another suffix, and this time it's m. And any kind of decimal arithmetic works this time.
Where is the m based on?
If I remember correctly, they compared what other languages use, and I think they wanted, like, for big ints, they couldn't use I, which would have been a nice suffix, because that they wanted to use it for imaginary numbers. I'm not sure. So. So here I think they looked at what other languages used and just picked the most common ones.
And if you want to use like decimal numbers and big ints, would you then use MN or
big decimal? Yeah.
Or
it's not yet entirely clear. It's very much possible that decimal computation will actually be big decimal. So you would have, but we will see. We'll see.
Okay.
It's a good question.
No,
But it absolutely will be floating point. I just quickly, it absolutely will be floating point, and maybe it will be a big decimal that automatically adds precision as necessary.
okay.
And categorizing values is another topic where that is not as convenient in JavaScript as it could be. And there's several reasons for that. First, if you think, okay, I have a value, I want to categorize it, what kind of value do I need? Then you have to decide between type of and instance of, which is unfortunate because otherwise the difference between primitive values and objects is you can't forget, and you don't normally need to care about it. But here you need to. And then each of the two has its own particular sets of quirks. So you have type of, and where type of null is object. And for ECMAScript, I think it was for ECMAScript 6 or maybe after, they actually tried to fix that bug. They fixed it in a Canary browser, and it broke too much software on the web, so they couldn't eliminate the bug, so it had to stay. And additionally, you have, if you do type of and the value is a function, you get back function, which I don't like either, because in a way it should be object. Because if you do type of and the value is an array, then you get back object. So this is the only time where type of distinguishes different kinds of objects. So the kind of rule of thumb, type of is for primitive values, kind of breaks down here. And instance of does not work as soon as you receive a value from another so-called realm. And realms are, if you get a value from another frame on a web page, then that different frame has its own set of global variables. And if you receive a value from there and do an instance of here, then you're using, say, instance of array or something. Then you're using the local array to check for this instance of relationship, and that doesn't work for an alien entity. And you shouldn't have to think about that. So that shouldn't be something you would have to know. And I think that is fixable possibly via a library, but that's still something I'm exploring. Then there are features that are inspired by functional programming. And as opposed to functional programming, C-style languages make a distinction between expressions and statements. And the effect you then have is that you have two versions of the conditional statement or of a conditional operation. So on one hand, you have the well-known if then else down here. So that is a statement. On the other hand, you have the ternary operator that is the same thing, but now as an expression. In most functional programming languages, you can just use if then else up here without any issue. So that'd be nice, but C works differently. And one proposal to fix that are the so-called do expressions. So what you do is you annotate a block with the keyword do, and then stuff internally is treated, the whole thing is an expression. So you could do more. You could have multiple function calls. You could do something more complex setup, for example, which is convenient for constants. So that's one thing. The other thing is that internally, these are treated as if they were expressions too. So here I don't have to return anything, I just write yes. And these are the so-called completion values, so that it's kind of the last value that JavaScript sees when it executes the block. And then here you return yes or no depending on what the value of some bool is. This is something a little bit more complex. Here actually we could make this a constant. Internally we have a switch statement, and once again this returns, and you can use something that's convenient, and that is switch is normally not an expression, and here you can use it to set up a variable. So I find it convenient, and I think especially for React, sometimes people do some weird stuff in order to stay within the expression space when you have React code, and do expressions help there.
Okay, omit break here. Okay, omit the break statement.
Good question. No, you can't, because then you have a fall through. Then you have a fall through. I thought we were going to ask, do you want to make a break? And I was like, no, I should start.
You could maybe do return.
Yeah, I think if you want to do I don't think a return is going to happen, but I thought about the same thing. And usually I think you'll be able to nest it in some tricky way so that you don't have to do a return. If you want to do a return, you're probably going to do an immediately invoked function, and then you can do a return. But do expressions are one of the last cases where you still need immediately invoked functions. This is a weird pattern. And with do expressions, the last use case for them more or less goes away. So that's nice. Another functional programming feature that is nice is so-called pattern matching. And this is convenient whenever you have nested structures and they have all kinds of data in them, and you have this kind of switch on what is inside an object. So whenever you, for example, if you work with abstract syntax trees or any kind of more complicated nested structure of JSON data, then this is kind of nice because you can use structuring here. You can either check values or even extract, like the content length here, extract data, and you get a nice way of distinguishing the different cases in a very concise way of checking data.
Could this clash a bit with the value types? Say, you could say, I want to compare resource to the value type status 404. Wouldn't that be solvable with basically just a regular switch?
I like it. It's a very interesting idea. So, so I think the point is, with value types, switch becomes a lot more useful. Absolutely right. Very good point. On the other hand, this kind of going into the data, that will be always useful, and destructuring and kind of looking what's inside it. So yeah, good point.
So, quick question: how does it know S will be a variable?
How does what?
Like, how does it know that S is a variable that you want to extract the value to, rather than you're passing in something?
I like it. That's a good point.
Because you're not saying like let S or something.
Absolutely, very good point. How do you distinguish between now it's a value that you want to match as specified, or like input versus output?
Mm-hmm.
To be honest, I don't know. But the rule may be that if it's not a variable, it's checked, and if it is a variable, it's destructured against. The thing is, I have never tried destructuring with fixed values as opposed to variables. What would happen if you would do a const of an object, and if that's even allowed in a const?
I know in Elixir they use the pin operator. Like it's a caret and then before the variable name, and then you say has to match the value of this variable.
Yeah, that makes sense. And this is still in a very early stage, and they changed it unfortunately multiple times. So there was one where it was a lot more clever, where you could configure and where you could even you could have regular expressions as after the when. You could have classes, and then it would be an instance of check, and you could have a regular expression, and then it was kind of a regular expression check. So that is still very much in flux. But I know from having used ReasonML that this kind of matching is very handy if you do any kind of processing of trees of data. Another one is the pipeline operator, and that one is immensely popular. So whenever I just mention it briefly on Twitter, those are my most retweeted tweets. And it definitely is nice. So who of you have heard of the pipeline operator? Raise your hand. Okay. So again, I'm guessing like 75%. So what it is on the one hand, if you have this nested normal way of function application, this is how it works. And when it's deeply nested, it's not as intuitive anymore. Because when you have multiple processing steps, you're thinking about it, I start with this value, then I transform it, then I transform it again. So you're thinking in kind of this pipeline as if you're using a Unix shell. And you can use the same, and this is the exact same expression with the pipeline operator. So that means that these two expressions are equivalent. So you have one style of function application like this, and then you have the pipeline operator where this is the argument and this is the function. But and there are actually two competing proposals, and the proposal we're looking at is called smart pipelines. Yes?
Are they bidirectional? Can they go the other way?
No, they can't. No, just one direction.
Is the syntax based on F# or other way?
Maybe, I don't know, but it's kind of if I remember.
With cross applications, you can
functions
and then you
yeah.
have.
It may be. I'm not sure what the actual inspiration is, but they're not like it's amazing. Like you can't always choose freely, so you have. But it may be. I'm not sure.
Yeah, that's based on how you handle the values you pass on from the
Oh,
previous.
for sure. I mean, the different. I think Elixir has a different version of the pipeline operator, where whatever you pipe in is inserted as the first parameter, something like that. So
Yeah.
both, and this is just pure function application here. Both styles are useful, but we'll see something on the next slide that is kind of cool, because the smart pipeline operator proposal includes, well, I think it's optional, but it would be, I'd be very much in favor of it. It includes partial application. So what you'd have is some kind of a special symbol, and then the above, this kind of first argument, special symbol, so hash symbol, and then another argument is equivalent to this function here. So, and that's really awesome when you work with tool functions, because what you can do now is, if you have a map function that you import from somewhere else, you can actually almost use it as if it were a method. So for any kind of tool library, think Lodash or similar, it's just awesome how much more you could do if you have this kind of feature. Any questions?
Well, I know from Swift you can define your own operators. Isn't that a logical first step in implementing this, or is there like a JavaScript fundamental reason that you can't offer to users that they define operators?
We will get to that. There'll be a slide on for the. It's a good point. Could you? Yeah, I think you could reasonably, but the partial application bit you couldn't do easily.
No,
it could be a separate thing, but I think for this, I should point here. This is only I see what I point here. Right here. So I think the partial application thing, it's good that is tied to the pipe operator, because if we're a general thing, then you have a difficulty like how far is the scope and so on, and it would become kind of strange. Another topic for the future is when you look at concurrency. Right now, the main construct for concurrency, at least in browsers, is the Worker API. And recently it has been added to Node.js as well, so that's really nice to see. Because in the past, Node.js is a bit deviated from web browsers, and occasionally done. For example, I recently found out that if you set timeout in a web browser, it returns a number as a handle, and in Node.js it returns an object. So it's not a big deal because you will use it correctly either way. You're not interested in particulars.
Also, the Worker API, the actual options that you pass in after the file are different.
Oh, shoot. Oh, all right, okay.
So they're completely different. The first part is a file, the second part different in the browser.
Shoot. But they're slowly walking towards being more similar to web browsers, and also them adding ECMAScript modules will be awesome. So that is something that I'm really very much looking forward to, having ECMAScript modules available on Node.js and on NPM everywhere, and that will be a major milestone for Java, for the whole JavaScript ecosystem, where a ton of things will become much easier. So workers are now standard, like more or less the same on Node.js and in web browsers. But the problem with workers is that they're relatively heavyweight. So whenever you start a worker, it comes with its own global variable, so it's not very lightweight. So if you want to start a lot of threads, you can't do that. So you need to do something like work stealing or some kind of clever, so you have say a fixed set of 4 workers, and you pass on work to these 4 workers. you can't do something that, for example, Erlang, and in Erlang, threads are very cheap, so you can't just create lots of them, and it doesn't matter if you don't have to reuse them because they're so cheap, and starting them is cheap, creating them. So having something similar in JavaScript would be really nice. When it comes to the standard library, this is probably the one aspect of JavaScript where the language has the most catching up to do, apart from maybe concurrency, when it comes to other languages. And with concurrency, it's actually an advantage that JavaScript is behind, because you can learn from the mistakes that other languages made, and you can do it better. With the standard library, if you look at many functional languages, and if you look at Python, there's a lot more you have available, and occasionally it's really painful. Well, at least now we have maps, thanks to ECMAScript 6. But there's still, it would still be nice to have more. And I want to look at a few aspects of the standard library where things are missing, in my opinion. Currently, if you look at some of the global variables, these are actually poor man's modules. So especially math. Math is basically a workaround because JavaScript didn't have modules in the beginning, and somehow they had to put all these math functions somewhere, so they put them in this kind of namespace object here. And there are a lot of functionality in the object uses object as a namespace for tool functions. And one possible, I would very much love to have it, but currently it's still controversial whether or not this is going to be added, would be to have a special protocol for built-in modules, and then you would just say, import the keys from this kind of pseudo URL, and you would be importing something built in, and then you would use it. And if you contrast that with the poor man's module here, I think it's a lot nicer. And documentation-wise, I just like modules, so it would be nice to have that. In a way, JavaScript, the benefits would be that JavaScript becomes more modular, so engines would start up a bit more quickly because you could load functionality on demand. You may also have reduced memory consumption if you load less, if you only load what you need into RAM. But the point is that who of you have heard of the internationalization API? So that is, okay, less people now, I think we're like 40, 50%. And this is also an ECMA standard, and that helps with anything string or internationalization number, concurrency formatting, comparing strings in a language-sensitive manner, sorting, and so on. And that is accessible in most engines now, via the global variable, and that is called intl, and without an E at the end, so INTL. And the contents of this global variable, that is actually loaded on demand. So I was arguing with someone with a friend of mine, well, but the modules are loaded on demand, and then he says, no, you can't do that too for the poor man's modules if you say that if you access a member. So unfortunately, that's not an argument in favor of modules. But one argument is that if you import a function from a module, you don't have to dynamically find out where it is, so access is faster. So here, for example, you directly point to the function, and the invocation here is faster than here, where it has to dynamically look up property keys of object. And one thing that I envy Python for is that they have tools for working with iterables. So there's So right now, for example, a set is iterable. So what you can do here is anything that's iterable can be converted to an array. So that's nice. So if you were to implement your own data structure, that would work just as well and could be converted to an array this way. So that's a standard mechanism that's called iteration in JavaScript. But once you want to do anything with an iterable, you have to convert it to an array and then you filter it afterwards. And with these tool functions, you could directly filter an iterable and it would produce a filtered iterable. And if you had that for both synchronous iterables and asynchronous iterables, you could do a lot with streams, for example. So it would open up a lot of possibilities.
Could you solve that using as a library? Because that filter call there is basically just a bind of the statement above.
All right, let me distinguish. Could you solve it via, so that's kind of two questions. So absolutely yes to the first question. And there's actually been a discussion of, because having stuff built in has pros and cons. It ages if it's built in. So upgrading, as you can now on NPM, you can increase the version, is possible in NPM, and with a standard library it's not as much possible. On the other hand, documentation and kind of availability and people know it, like there's one unique standard, those are definitely advantages in favor of this. And I would argue that it's such a core functionality. We already have filter and map for arrays that would kind of be logical to at least a minimum amount of useful stuff to add that to the language. Because if you look at functional languages, they have almost always built-in stuff like zip, for example, or, well, filter map or equivalent.
Does this not just mean we need RxJS in the core? Because this is the kind of thing that we're talking about when we build these streams of data.
Yes.
Yeah.
So at the moment we already have asynchronous iteration, which is kind of the pull version where RxJS is more pushy. So there are people arguing in favor of that. It's not yet clear what's going to happen. It's not as urgent now that we have asynchronous iterables. That's a good point. Another thing that especially has become popular with React, and which enforces a lot of, or favors a lot of functional patterns, would be working with immutable data. So you basically you have data and you never change it. You always create fresh copies. So that's a technique from functional programming. And the advantage is that it eliminates a certain class of bugs, because you can have every data you have is unique and no one else can do something that breaks what you are working with. So you are the owner and no one else changes it, and side effects are not an issue. And at the moment there are other libraries too, but these are two popular ones, Immer, and they demonstrate two different approaches. Immer does its work via objects and arrays, and it just copies those, and that's very convenient. So that's very lightweight. And on the other hand, you have immutable JS that's a lot more heavyweight and comes with its own relatively quite powerful data structures. Another topic that is important is better support for dates, because at the moment the best practice for JavaScript dates is basically don't use it. And there are good libraries out there. So one library I've used a lot is date FNS, so date functions. There are others out there. And TC39 is working on a new and better datetime API, and that one is called temporal. And then the month, the one will finally be January among dates, and a lot of time zones are always something that can kind of make dates wrong. And I had one script that I executed while I was traveling, and then it worked differently because it was in a different time zone. Because time zones are so implicitly in the current date API. So now we get into things that may not be needed.
Use this features.
Thank you. I was hoping for that. So the optional chaining is incredibly popular, possibly even more popular than the pipe operator. And the way you use it is like this. So you have chained property accesses, and with a question mark, you can say, well, the object may be zero, may be null or undefined. And if it is, I just return undefined, so I can use the dot without ever getting an error or an exception. So that's definitely nice. And I don't think I'm even arguing against optional chaining, but just for the reason that it's very popular and I don't want to have too many enemies. But the other reason is that, and it's nicely concise, so it does help, but I find it helps to think, well, what if we didn't have it? What would be the alternative? And arguments against it would be that if you have a data structure and you nest very deeply, then you very often have something very fragile. You go very deeply, and if you make a change, it affects lots of parts of the system. So things are not as isolated and as easily to move around anymore. Another con, so you should never need it. You should never have these deeply nested structures, ideally. I'm hearing the enterprise developers now. And the other reason is that tolerance can hide problems. So if you use this optional chaining operator, you can get very far without there ever being an exception. Actually, you would like an exception to be thrown, because you have a null in between and it still keeps going, and you would like an exception. And IOTS, for example, that would help you with that because it does a real schema check.
But it can still return a zero if you make an expression.
Which
The
one?
result, if you make an expression, it can still return a null, and you can still check on the null.
Yeah, yes, you
But
can.
you don't know where the null comes from. Is it a
Ah.
property,
Yeah.
or is the property of
Yeah,
property
yeah,
of a property?
So you may have a problem. You may have a null where you didn't want a null, and then you still keep going. It doesn't stop you. Whereas otherwise you would be stopped and you'd find out that there's a problem very much earlier, and then the problem manifests itself much, much later and you don't know why.
That's interesting. I used the option flag a lot in C#, and I never had this problem.
Well, that's good to know, for sure.
You don't have to put question mark everywhere. You can do question mark, dot something, etc.
Yeah, and it just
So
keep
just
going
put it
and
in
just
where you
run
need to.
forever.
And then what there's
But and I think if you use something like IOTS combined with optional chaining, you'd be fine usually because you're already doing the schema checking. And it's just not really. It's more something to think about. I find the argument interesting. What if we didn't do this?
Definitely beats nested destructuring with default value to an empty object.
You could do that as well. Yeah.
That's what I now have to do sometimes. So.
Yeah. Interesting.
Totally sucks.
Yeah. I have to try that out in code. Interesting idea. I'll keep it in mind.
Object as the default value to the property.
Yeah, you can. That's true. You Okay. So the alternatives is you write a helper function that extracts data and then warns you if there's a problem, but it's still concise. The other option is to just normalize and clean data and just put it into something simpler. So that's right now for a small code base that I've written, that's written in TypeScript. I'm not using IOTS yet. And what I'm doing is I'm translating from input JSON to output properly typed TypeScript, and it does some cleanup and moves stuff around so that it works better for internal purposes. So this kind of translating the data you parse into something that you don't need this optional chaining for. That's another possibility. Operator overloading, we talked about this before. It's definitely nice to have that, especially if JavaScript should add more stuff in the future. And for big int, you already have internally some kind of operator overloading. But maybe we could stick to the operator overloading for the built-in stuff, and we wouldn't need users to be able to overload operators if we had infix function application. And this is just another point of I think worth considering. And here, for example, what if you implemented big decimal via a library, and here we created 2 big decimals, and we're adding them, and here we just apply the function infix. So it's not this prefix way of applying the function. We have this infix way of applying it. And the advantage is that if you are more nested, it remains nice. And the advantage when you compare it with normal function operation is that it remains readable even if it's highly nested. And you can add more operators. So if you do operator overloading, you have to stick with the operators that already exist in JavaScript. And yeah, okay, sure. Go ahead. It's yours anyway. You're not technically stealing. And as doing operator overloading in a second, doing operator overloading well in a dynamically typed language is a little bit more tricky. So infix function application would be something that you immediately understand and you would immediately know how it works, versus operator overloading where you would have to register something probably. So you have options of making it a method. This would be similar to Smalltalk, where you could do multiple dispatch. So there's different options where you would just register a table of possibilities. You were first.
Operator overloading be implemented using proxies. So like Python does it. Basically, you just wrap your object in a proxy, overload the plus operator.
And that is how Smalltalk does it. So with Smalltalk, even if you have a plus, then that is a method invocation that is sent to the first operand. But in JavaScript, they work differently, and I think converting them, well, it depends. It may end up being moving a little bit in that direction, where you dispatch to special methods.
I think type of or instance of a new keyword, which is basically a unary operator, is something you can overload in a proxy. If I remember.
Instance of, you can't configure. I don't know if it's new.
Check the documentation.
Yeah,
though. But it sort of looked like it was going in that direction, but it somehow felt incomplete on, well, why not go all the way like Python did?
Yeah. We'll see. I think we'll end up with a mix of where we kind of between where we have some stuff is special, but in the end you have like limited operator overloading that you need to opt into, and then you add it as kind of a method to a class or something. It's still up in the air how exactly it will happen, but it's definitely an option. So I really like multiple dispatch. So that would be my favorite, but we'll see where it goes.
Yeah.
Oh, sorry, you were a bit.
Sure. You mentioned in the last sentence there that the nested expressions remain readable. Still, I would expect the times there to be executed or evaluated first. How do you handle?
Operator precedence, I think that would be affected. So you would just go from left to right.
Yeah.
And if I remember correctly, that's how Smalltalk works as well.
All right.
Yeah.
So, but then doesn't your example make a case for why custom operators
No.
are required? Because you don't get the result.
Yeah, but only for math freaks. No, I don't know. Yeah, it's a
We're a programmer.
but for other people, it's easier to understand. It's just like. Yeah, but point taken.
So the infix function you were explaining there, it looks like you could also implement it with a pipe operator.
Definitely. And if you look at the blog post, that's kind of a companion to this presentation, I'm actually showing that the pipe operator makes it easier too. Already helps a little bit with the syntax, for sure.
But I never have seen the proposal for infix operator. Or
There isn't any. It's just Haskell, for example. Haskell has it. It's regular TKT.
Before you hop on to the next section, to go back to the date, I just wanted to check. Yeah, there's TZ announce where they actually do changes to things in time zones. How do you think we'd handle that in JavaScript? You already talked about where they tried to change the type of null.
Yeah.
And if time zone things are.
Oh, it'll be a totally new thing. So we will slowly forget about the old dates and use the new temporal API.
And then they'll ship in the browser the fixes, I assume.
You just evolve, you just go forward. You never eliminate existing stuff.
Right.
And have any of you seen the simulation of the very first web browser in JavaScript? So there was someone simulated the very first web browser in JavaScript, and it's amazing how many current sites still work in a web browser from, I think, 1990 or something, or 1990.
I have Netscape here.
Yeah,
Similar. It was even before.
Yeah. So it's amazing. So this kind of backwards compatibility is amazing. And so for JavaScript, you don't have a choice, but you can move forward. You can move away from old features and they slowly disappear in usage.
I suppose you use that time zone, like you say, America, Chicago, but say you use an obscure time zone and they move half an hour because they've got rid of daylight savings time, or so
you mean how are these tables updated?
Yeah, that's what I meant.
Oh my God, I don't know, and I think right now they're trying to eliminate daylight savings in Europe.
Exactly.
I think it's a popular, and I'd be very happy about that. And how do you update? I think it'd be a browser update, and they have internal updates.
Every half year, browser update.
Yeah.
The time zone database is updated several times
Daylight
a year.
saving browser
Yeah.
update.
Lots of changes.
So it should work. So with evergreen browsers, we're now in a relatively good position. So quickly, very smaller wishes. One thing I would like to have would be chained errors, so chained exceptions. For example, if you catch an unknown exception and throw your own custom exception with this kind of chaining, you can include the other exception that you caught and then annotate, and then if you later for debugging is useful because you know where the original problem came from. So that would be nice to have. It's very easy to implement, and there's a library on NPM that does that. But it'd be nice to have it built in. Composable regular expressions would be nice because very often you have a very long regular expression, and these are kind of hard to, what some people call write-only syntax. So it's easy to write, but really hard to read. And if you can compose it from other, so this is another this is another regular expression, and you could kind of compose it together, and that would make long regular expressions a lot easier to read and understand. This, you want to see that one? Right. So that's more of a niche feature for people who like regular expressions. At the moment, there's no way to escape text so that you can use it inside a regular expression, and if you want to replace a text multiple times, that would be a nice feature to have. But if basically you care if you work a lot with regular expressions, and I do, so that's why it matters. This would be nice as well. At the moment, that's another Python feature that's nice. If you want to access the last element, at the moment you can't do so via an index. And an alternative would be to add a get method. That's a method that, for example, maps already have, so there will be precedent for that. And I just like that for accessing the last element.
I'm not just putting
What's wrong with slice does -0? No, -1.
But then you get back an array, and then you have to get an access element 0 from that. But slice is nice because it does already support the negative indices, and that's cool. Enums at the moment, for the most part, TypeScript really is more or less a superset of JavaScript, and this is one language feature that TypeScript has that the JavaScript doesn't have. So it would be nice if we would close the gap between the two, and in general it would also be useful. So that's something that would make sense to add, I think. But these are smaller things, so they're not ranked. Not having these is not as does not make me as sad. All right, so that concludes our talk, and just to briefly, we've seen a lot of features, some of them syntax, but the biggest thing I'm still missing is when it comes to the runtime library. That it would be nice to have more things there. Apart from that, I'm fairly happy with where the language is right now. I'm waiting for ECMAScript modules to be available first class at NPM, or to be the only module type supported by NPM, apart from legacy stuff. And so we're living in good times. I think for a long time things got more complicated, and right now things are relatively getting more stable, and so at the moment we live in good times for web developers and for JavaScript programmers. Thanks for attending.